Having a good save system is quite important. If you get this wrong, your players can lose hours of progress, or worse, if you pick the wrong method, a save file can run malicious code on your player's machine, like I will show you later in this video. Thankfully, if you stick around, I will show you how to implement a safe and reliable saving method for your game. There's really no native way to save games in Godot, at least not at the time of this video. There are about 3 mainstream methods that people like to use, including the one recommended by the official Godot documentation, and they all have their trade-offs. I will show you all 3, I'll explain when to use each, and I will implement them in a real project. My hope is that you understand the logic well enough to adapt this to your game and choose the one that suits you the best. So this isn't really a code along with me kind of video, it's more of a sit back, have a drink, and listen. As always, if you have questions, and I assume a lot of you will, you can leave a comment down below. And if you wish to support me and motivate me to create more content like this, there is a link in the description for this as well. Now, I know some of you just want to see the implementation, so you can skip around to, whatever timestamp I'm going to put right here if you want to. Otherwise, I highly recommend that you stay for the little crash course on saving systems that I've prepared for you. Let's go. Okay, so I, for one, really dislike tutorials that only teach you the theory and don't really show you any kind of practical results. So what I'm going to do is I'm going to show you how to save data for this game in particular, but make it general enough so that you can understand how to expand it for your own game. It doesn't matter if you're making an action RPG or a strategy game, the concepts I will bring up in this video are relevant for any game. Some of you will recognize Ace Attorney characters, and that's because I made a series of tutorial videos in Godot about how to create a visual novel. This is exactly the same project, but don't worry, you don't have to watch all these videos. This is very much a standalone. Now, if you did watch all of my videos already, thank you. I did add a few more windows and menus behind the scene in order to prepare for the saving system. And unfortunately, I can't show you how to implement all of that without this video taking 2 hours. So you'll have to make the UI yourself. Now, if you struggle with that, feel free to download the project from the GitHub repository in the description. Oh, and before we start, I recommend that you use Godot 4.6 or above, since this is the version that I've used to make this tutorial. In this video, I will assume that you already have all the UI you need to make the save system, which is nothing complex, right? You need a new and load game buttons on your title screen, and you need an option to save and load your game somewhere in your menus. For simplicity, I will only have 3 save slots. It's up to you how many slots you want to have, if you want to have any at all. If you want your game to have an autosave feature, then you probably want to dedicate specific slots for this in your game. Also, I didn't bother implementing a confirmation window when loading the game, but keep in mind that it's typically safer to have one. What data are we going to save? This is the most important thing that you have to think about before you even consider implementing a save system. If you're new to game development, you might not know what is typically involved in saving a game. So you might be thinking that we can somehow create a snapshot of the entire game and restore it later on, but that's not exactly what happens, unless you want your save file to be the same size as the game itself. There's no magic. You don't just freeze the game itself when the player quits. Everything gets destroyed. When the player resumes a game, you have to figure out exactly what data inside of your game you need in order to recreate the game world, the player progress, the preferences, where you are in the story, etc. There are typically 4 types of data that you need to save. You have the metadata, which is all the data that is about the save file itself. Okay, so it's not about the game. You could have something like a timestamp in there. You can have a saving file version if you want some backward compatibility when you update your saving system. You also have the global GameState. So this is very much about your game. This is the data that persists regardless of which scene or level the player is currently in. It tracks the overall narrative and player progression. Data like this is often stored inside an autoload like a game manager or a progression manager. Anything from story flags to unlocked collectibles typically belong in that global state. Then you have scene-specific state, which is the data that changes depending on where the player is currently in your game. Typically, this is the most challenging part to implement because it requires serializing objects in the scene tree, meaning you have to create a text representation of Godot native types such as vector2 or color, because they can't just be saved as is. A common example of scene-specific data is the player position on the map of your scene, for example, which is often a vector2 or a vector3. Finally, you have the user settings. This is the stuff that you typically find inside of the options of your game. You can have audio levels, input maps, accessibility options, etc. You should not tie these values to a specific save slot. If the players want to play your game at 60 FPS, you shouldn't force them to make this choice after each new game. For that reason, you will typically store these values inside of a completely separate file like settings.cfg, and Godot has a built-in config file class to help you handle this kind of values easily. Now, at the end of the day, of course, you're free to do things the way you prefer, but a conventional file tree for the different kinds of save files you need would typically look like that. You have one file per save slot in your game. You have the settings, and you also can have the system.dat, which is more about meta progress. So like collectibles that you can see from the title screen of your game, for example. By the way, user is a special path that Godot chooses for player data. On Windows, it is inside the app data folder or library application support for macOS. If you cannot find it, you can open it from the editor, project menu, and open user data folder. In order to keep this video as simple as possible, I will mostly deal with the normal save slots, but I will also quickly show you how to set up a configuration file at the end. Before I show you the implementation, let's talk about the three main ways of saving your game in Godot and why you should choose one over another. The first one is resource. If you search Godot save tutorials, you'll probably find this method first. You create a custom resource class and then you add some exported variables for your save data, and then you use resourcesaver.save or resourceloader.load. That's it. It's one line each, it's clean, it's native to Godot, and the resulting .trace file is human readable as well. So why am I not recommending it? Well, resource files can execute code. A trace file can contain embedded scripts. When you call resourceloader.load, those scripts will run immediately. There's no confirmation, there's no sandboxing. So if a player downloads a save file from Discord or any modding site, and that file contains malicious code, it will run with full access. And you might be thinking, who would hack my little indie game? But it's not really about your game. It's about using your game as a Trojan horse. In late 2024, the God Loader malware infected over 17,000 machines through malicious Godot resource files. There's an open proposal on Godot's GitHub from 2022 asking for a more secure resource loader, but it still doesn't exist at the time of this video. Now, if your saves never leave the player's machine, which is to say there's no sharing, there's no mods, there's no Steam Workshop, there's nothing, then I think resources are fine. But the moment players can exchange save files, you have a pretty big security hole on your hands. This is why I can't, in good conscience, recommend this method, even though it's the easiest. Alright, next one is FileAccess. This is Godot's binary serialization. You open a file with FileAccess, you call store_var with your dictionary, and then Godot will handle the rest. To load, you simply call getVar and your dictionary comes back exactly as you saved it. Pretty easy. The big advantage is that there's a support for native types in Godot, like vector3 and color. They all serialize and deserialize automatically. You don't need to do any sort of conversion yourself. And crucially, store_var is secure by default. It's not going to execute code unless you explicitly enable that. The trade-off is that your save file is binary. So if you open it in a text editor, you'll see that it's just a bunch of gibberish. You can't really easily inspect or debug it without writing some extra code. Finally, we have JSON. JSON is the universal data format. It's human readable, it's editable in any text editor, and it's completely safe because it's just data, there's no code execution possible. The downside is that JSON doesn't understand Godot native types. For example, if you try to save a vector2, then you'll probably get a string like this, but you can't really load this back and have the vector2 unless you write the conversion function yourself for every Godot specific type. For simple data like strings, numbers, booleans, or basic dictionaries, JSON can handle all of them automatically. This is generally my preferred method because the human readable files make it very easy to test your game by editing these files yourself and try out different sections of your game. Here's the comparison table that shows you the trade-off for each of these methods. You can see that each of them has one major drawback. For a simple visual novel, I will generally recommend JSON. But like I said, I'm going to show you all three methods and save Godot native types such as vector2 and color and JSON to explain to you how you should deal with them. Now for this game, here's the data that we will be saving. A save version, of course, you should have this no matter what your game is. We're going to have a player name, which is just a string. We're going to have a chapter ID, which is the player progression in the story. We're going to have a dialogue index, which is going to tell me where in the chapter the player stopped. We're going to have choices made, which is an array of string to keep track of the choices made in the story by the player. Then we're going to have a dialog box position and a dialog box color, which are two native Godot types, vector2 and color, to show you how to save those. I'm also going to have character nicknames, which is going to be a dictionary of string values. And finally, a timestamp, which is another example of metadata, just like the save version. So we have a bunch of different types to save, and I can show you exactly how it happens with each saving method. Let's get to it. SaveManager. We will create a SaveManager node to take care of everything related to saving and loading data to have it all centralized in one place. Generally speaking, you want to be able to save at any moment, no matter what scene is currently active in your game, which means that the SaveManager should always exist while your game is running. Well, that is precisely what autoloads are for. Create a file named savemanager.gd and open the project settings before adding the SaveManager as an autoload inside the Globals tab. We are going to create a save game and a load game function inside of our SaveManager. That way, when you need to perform either operation, you will essentially be able to call savemanager.savegame anywhere in your codebase. Here's a simple version of what it might look like. This is usually inside the callback function of a save button. Now, in my case, I won't be passing the data to save directly inside of the savegame function. I'm just going to provide a save slot index. This is because more often than not, the data to save is not necessarily accessible in the scene currently active. Usually, it's scattered around your node tree, making it a bit annoying to gather everything back together. Here's a simple way to deal with this. Create a GameState autoload, the same way we did for SaveManager. This GameState will be in charge of storing all the properties you want to persist inside of your save files. Here's mine, for example. It contains all the data I will be saving in my save files. Something like the speaker box position would typically be saved as its string value directly, like left or right, but I will bind it to actual vector2 values to show you how to save these native Godot types in JSON format. Add a reset function as well, something that's always good to have so that you can start fresh easily when you create a new game. And you will also need a toDict and fromDict helper functions to make the SaveManager's job easier later on. toDict will transform your game state into a dictionary that you can easily save. Don't forget to add the timestamp in there. FromDict will restore your game state from a similar dictionary that you will parse from your save file. Of course, inside of your codebase, you will want to make sure that the game state autoload is always updated when it should. For example, here are a few callback functions associated with my main menu. Now that everything is gathered in one place, all your SaveManager has to do is interact with the game state to either save the information inside of it or recreate the game state with a pre-existing save file. Here's what you need in your SaveManager. You want two signals to tell your game components when the game has been successfully saved or loaded. I have no immediate use for them, but you might. For example, to display a little toast notification in your scene when the game has been saved. Since I'm going to show you 3 different ways of saving your game, I am adding this enum to easily switch between saving methods. You do not need this if you already know what method you want to use. This is just for my convenience. The default folder where save files are generated is user in Godot, but you can specify a different location if you wish to. In my case, I will use the saves subfolder. The SaveManager is also a good place to keep a constant property representing how many save slots you want to allow in your game. You can reference this max slots value when creating the list of available slots to load your game from, for example. Finally, you want to keep a version of the current saving system you're employing inside another constant property. This will allow you to know how to interpret different versions of save files in case you update your SaveManager. And that's about all the properties you will need. In the ready function of your SaveManager, just make sure that the save file location you've chosen actually exists. Now let's implement the save and load game functions. As I've said, I will be showing you 3 different ways to save your game, so the only thing my save game function will do is to redirect to the appropriate saving function associated with the method currently in use. After that, I simply fire my signal to tell the game that I have successfully saved the progress. Load game function is exactly the same, I'm just using the relevant loading function. Let's also add a utility function to help us build the full path of a given save file easily. The only thing we need for this is to know the slot number and the file extension, which will differ depending on your saving method. It will be .json for JSON method, .dat for FileAccess method, and .trace for the resource method. Alright, so first let's take a look at the JSON saving method because it's the one I generally recommend and it's also the most complex. A JSON file is essentially just a very long string which is a representation of the data you want to save. Very simply put, the only thing we have to do here is to get the current game state, stringify it so that the whole dictionary is converted into a long string, then we open or create the appropriate save file, and then we add the string representation of the game state inside of it. Easy, right? Well, not so fast. You can only stringify your game state if all it contains are strings, integers, floats, booleans, a dictionary of these types, or an array of these types. JSON can handle all of that natively. And luckily for us, a lot of the data we want to save are already handled. All of these, for example, are text values. Integers and floats are converted into strings on the fly as well. The only real issue is the color and vector2 right here. These are native Godot types. They do not have a pre-existing string representation, so we have to make one before we can stringify our game state. Let's transform the vector2 variable into a little dictionary-looking string representation like so. Internally, the result will look like this, which is something that the JSON can interpret since it's a dictionary. As for the color, there are different ways that a color can be represented in string form, but one way to do it is to grab the red, green, blue, and alpha channels and insert them into a dictionary. These 4 values are enough to recreate the color from scratch afterward. And we're done. Now everything inside the game state is either a string, a float, or an integer, so it can be stored inside of our JSON file. After saving your game, your save file will look like that. It's easily readable, right? You can even manually change the values yourself to load the game with different parameters or a different progression. With that method, you also make it easier for people to create modes of your game if that's something you're considering. Now, to load the game, we have to rebuild our game state, read the save file, parse the content, and then you can recreate the game state with the fromDict function. However, once again, the only properties that can't automatically be rebuilt from their string representation are the speaker box position and the speaker box color. But since we know how to interpret their string representation, we can recreate the vector2 and the color instance just like this. Another thing you don't want to forget is to convert your integers properties back into integers. The reason I'm doing this is because JSON does not distinguish between integers and floats. So when you parse the content of your save file, everything is interpreted as a float by default. Your load function is in theory complete now, but you've let the door open for a lot of potential problems along the way. What if the save file doesn't exist? What if you can't open the file? Or what if the content is corrupted? To build a more robust code, you have to account for all of these potential problems, so let's add a few safeguards here, here, and here. And now we're really done. You can now save and load your game using JSON files. If you're handling different native Godot types, you will have to find a way to stringify them yourselves, of course, but it's nothing a quick Google search cannot solve for you. Now, let's switch to the FileAccess method. Let's start by doing the same first steps we did for JSON. Transform the game state into a dictionary, open or create the appropriate save file, except this time the extension will be .dat, and then don't stringify, but call fileaccess.storeVar with our data. Okay, so now what do we do with the color and vector2 instances? Well, nothing. That's quite literally it. We're done. FileAccess already handles native Godot types for. If you've watched the JSON method right before, you might be wondering why even bother serializing stuff yourself for JSON if the FileAccess method is that easy. Well, it's because your save file looks like this. It's binary data, so you can't make sense of it, and you can't rely on it to debug your game without writing a bunch of code to interpret all of this. However, if human-readable files are not important for your workflow, or if you're saving lots of native Godot types and you don't want the conversion overhead, FileAccess is the cleaner choice. Here's the load function. As you can see, it's also extremely basic. You just use fileaccess.getVar and restore your game state with it. End of the story. Now let's take a look at the resource method. Believe me or not, this one is even shorter than FileAccess, partly because you're using a native Godot type, the resource, to save your game. For this to work, however, we have to create that resource. So let's create one very quickly. We're going to call it save data. Just list out all of the things you want to save, including the timestamp, and provide some default values. Easy enough. Now, in the save function, you'll want to create a new instance of save data and fill it up with the current data you have in your game state. But here's the thing, you do not need to transform game state into a dictionary this time. The resource doesn't need this. You can just access the game state directly and assign properties just like this. Oh, and also create the timestamp while you're at it. Then, the only thing you have to do is to call the internal save function of the resource saver class, and you're done. It's basically a one-liner. For the load function, you can use the resource loader class to load the trace file. This load function has a type hint and a cache mode parameter, which might or might not apply to your situation, so I do recommend you go read the docs, but for now, this will do. After this, just make sure the data you loaded is actually a saved data resource, and if so, you can update your GameState from there. Don't forget to duplicate dictionaries and arrays, because these are references. If you don't duplicate them, when you eventually update the properties during the game execution later on, you will be affecting the save resource at the same time. If you wanted to have some sort of auto-saving feature, that's actually the kind of behavior you want, but still, I would recommend to have a clear distinction between your game state and your saved data. Now, here is how the resource save file looks like. It's a resource, just like the Godot themes, so it's very readable, and you can of course change the values if you want to. The downside of the resource method, and it's a pretty big one, is that you can have scripts inside of trace files. That means if a player downloads a save file online, for example, internally it can look like that. Notice the little malicious script inserted inside of the ready function. This will fire as soon as the player loads the save file, and it can do all sorts of nasty stuff, such as deleting files, stealing credentials, or even installing malware. Alright, that's it for the 3 mainstream ways of saving your game. Now let's talk quickly about the config file I mentioned earlier. Like I said, some parameters of your game are actually things you want to load no matter what save file is being used, because they pertain to preferences about the game UI, for example. They are not tied to the progression, and players typically want these values to stay the same no matter what. In my case, speaker box position and speaker box color are typically things you don't want to insert inside of the normal save files, but rather inside of the configuration file. So let's do that now. I'm going to remove the properties from the game state and the SaveManager completely. Since I am updating the SaveManager, I will also bump the version to 2.0 so that I can add backwards compatibility for the 1.0 save files if I want to. And in this case, whenever I load a 1.0 save file, I would simply need to erase the speaker box properties from the data and update the save version of this file just like that. Now create a new autoload called SettingsManager, which basically fulfills the same role as the SaveManager, but only for the configuration related properties. A common file extension here is CFJ for configuration. Like I said before, Godot has a config file class that we can use to read and write from a configuration file. In the save settings function, create a config file and set the values. You'll notice that nothing needs to be converted to strings here. Just save the file and you're done. In the load settings function, again create a new config file and this time load the data from the unique configuration file you have. Then reassign the properties and that's it. Since we want to load these settings no matter what, simply call load settings inside of the ready function of the settings manager. That way you will always load the correct settings as soon as your game starts. And as for save settings, you will have to call it every time one of your properties change. In my case, I will update the callbacks of my main menu just like that. Now as soon as one of the values change, it will be saved immediately. Here is what the configuration file looks like. You can also edit this by hand if you want. As long as the values make sense, your game will know what to do. And that's it! You now have 3 different ways to save your game in Godot, and you can choose the method that suits you the best. If you're still unsure, I recommend that you start with JSON because even though you have a bit more code to write up front, it's the easiest one to debug. There is a GitHub repository in the description with the source code of this video if you need it. I hope I was able to help you understand how this whole thing works. Drop a comment if you have some questions or if there's a safe system topic I didn't cover, and consider subscribing if you want to see more tutorials or game-related content. See you in the next one.